So this is fine. Trans 6-methyl-3-heptene is fine. 6-methyl-3-heptranzine I'll be fine with. Whatever, if you put the trans in there, that would be great. Okay, now I'm going to try something different. I wanted to show I could write this on the board maybe if it doesn't work. I'm going to try Miss BQ's fancy document camera. Show you one of them in the book. Number 44 has some cis-trans polymers. I don't know how to use this thing. Maybe I'll try to turn the power on. Oh. Okay, and I think I have to change this. Oh, it's HDMI too. Oh, it's up there. Wait, how's it? Oh, it's just gonna. On the other cameras, there's a freeze thing. Maybe I'll just hold it. Oh, sorry. You might want to write this down. This is number 44 in the end of the chapter. I'll bet this one is assigned. B. Yeah, we're going to do B together. Yep, it's 44. It's not assigned? Okay. What is? What around it is?
42, 43, 47, 49.
What about 34?
34.
No? Oh, gosh. I'm turning into a softie. Look at 34. That makes me laugh. You got 4 structures there. Each of them has 2 double bonds. This is the way our authors are. These are the Zoom dolls. They will come up with stuff that you think, how in the world would you come up with this? And yeah, look at, they're asking, which would you expect to have the same physical properties? And you have to, really what it's asking is, which of those structures are the same thing? Because if they're the same structure, they'll have the same melting point and boiling point and all that. Which are trans isomers, which do not exhibit cis-trans. 34 is a toughie. That's a good one. And I don't know why I didn't give it to you. I should have. So let's take a look at B. I guess, oh, maybe. Oh, yeah. Okay. So, I thought I could just freeze this thing.
Maybe you could freeze it on that one. Like that one, I think that's.
I don't know how to freeze that board, though. Do any of you?
Isn't there a freeze?
Yeah.
He tried that, but there's no cards, so it doesn't.
Yeah. All right, so I'm going to hold it. Not for long, though, because the book's falling off. What is the name of that compound? B, on the top.
Parent.
You have it already? No, don't say anything yet. I want everybody to see if they can digest this a little bit. Nathan, what's the name of the parent? Cis-3-heptene. Do you agree with that?
Mm-hmm.
Sophia, do you agree with that? Okay, well, I'll show you. Would you agree that the parent starts here, this longest chain of carbons, 1, 2, 3, 4, 5, 6, 7. So we've got a heptene. And the parent, notice, continues on the same side of the double bond as where it started. Start on the bottom and ends on the bottom, so that makes it cis. Okay? Then we have 2 functional groups. So, okay, there's our parent, there and there. So we have a methyl group up there and an ethyl group up there, yeah? Yeah. Methyl group is in what position?
3.
Ethyl group is in what position?
4.
Right. So we got a name for this thing? Nathan, rattle it off.
4 ethyl, 3 methyl, 6 3 heptene.
4 methyl.
Ethyl.
Yes, 4 ethyl, sorry. 3 methyl. Cis. 3 heptene. Always put the parent last in the name, but identify it first before you do anything else. And once you identify it, if you need cis or trans, whatever, just write it out. Because that's going to anchor the name of it. That will always come last. And then you identify your functional groups up here. Yeah? I had brought something. I brought a little show and tell and smell. And literally, I said that on purpose because I have a couple of organic compounds. These are polymers, which are long, huge molecules of repeating things. There is a double bond present in the thing that repeats. This is polyisoprene, but where around that double bond, the parent is a trans arrangement. Notice it's like a plastic almost. You could stick your fingernail into it, but it would be very hard to break this up. You'd have to really put a lot of force into breaking this up. And smell it when you get it. Literally, chemistry. And then this one is the cis arrangement of the same compound. These are both polyisoprene, cis, trans. Not much smell at all on this one. But you'll notice a very distinct difference in the properties of these two, even though they're the same compound. One is cis and one is trans. You're first. And just go ahead and pass that around. So I'm done with that. Don't write that down. I'll just tell you that there is a third type of isomer. We've learned structural isomers. That was what that BA was on in the beginning of the hour, where you rearrange, you got to have the same chemical formula, different arrangement of atoms. Structural isomers. Then there's geometric isomers. That's where you have to deal with the cis-trans. A third type is the stereoisomer. Occurs when you have a carbon that has 4 different things around it. And that could allow for a different arrangement of those 4 things, and so you can get isomers in that way too. Stereoisomers, where you get chiral carbons. It's a little bit more complex than we want to go into, and remember, our curriculum is guided by what the College Board says we have to teach. This is not in our curriculum, so I'm just telling you this third type of isomer. If you take the organic class here, you'll see it and you'll learn about it. We're not doing it. There is a reading assignment tomorrow too. Did you know that? Okay, keep up with those reading quizzes. Tuesday and oh, don't be dramatic. Tuesday, Thursday this week, reading quizzes. Actually, the reading quiz is on this, just reactions of hydrocarbon compounds. So I would be doing this today with the reading quiz, except we had planned for a lab activity using molecular models like these things. Unfortunately, we don't have enough for 2 classes to use them at one time, and since this hour, Mr. Hubble has this class and I have this class, I said that he could do the lab today and we'll do it tomorrow, so I've got to kind of rearrange what we're doing. So all that to just tell you I'm going out of order strategically for a reason, but after tomorrow we'll be in the same place again. So I'd like to cover just a couple more things, and we'll be great to do this on time. I'd like to just introduce 3 different types of organic compound. So far, we've just dealt with hydrocarbons, with the occasional substituted, like a halogen. When I say halogen, do you know what that means? Halogens are a family on the periodic table. Which one? Group 7, or 17, depending on how you number it. The fluorine family. Those are the halogens. So you've seen chlorine as a functional group, bromine, you can have iodine as a functional group. Rarely fluorine is a functional group on organic. So I'll just use the word halogen, and get used to that if you need to write it down for yourself. A halogen is a group 17 element. They kind of just fit right along with, because the halogens can only make one bond. They already have 7 valence electrons, they got one unpaired electron, they make one bond. They're kind of like hydrogen, like that. Now we're going to get into some compounds that have oxygen in them, like alcohols. Oxygen in organic chemistry can make 2 bonds. How many bonds does carbon make?
4.
4. Hydrogen makes 1. Oxygen will make 2. Because oxygen has 6 valence electrons, it's got 2 electrons free for bonding, and so it'll always make 2 in organic. What did you think, Jane?
The smell, it's very strong.
It is kind of a strong smell.
I thought it was.
Oh, yeah. How did you like? You literally.
I like it.
It's a good.
Did anybody else like it? Am I the... Thank you.
You just got. Yeah. Don't.
Wow. Smells like 1,000-year-old raisins.
Yeah.
I don't get any raisin smell. But...
Maybe a really good one.
All right. So anyway, you're going to see for all the compounds that contain oxygen, in every case, the oxygen is going to be making 2 bonds. I guess it's dangerous for me to say all. Carbon monoxide is an exception. It can make, there's a triple bond between the C and the O, carbon monoxide. But we won't be dealing with that in organic chemistry. So anyway, we just need to worry about identifying alcohols and being able to name them for right now. Later on, we'll get into what kind of reactions will occur with alcohols. But for right now, just be able to identify this is an alcoholic compound because it's got the OH in it, somewhere on the molecule. And then we're going to name it differently. Rather than ending with ane or ene, when you see an alcohol, it's always going to have OL at the end. So you're going to drop the ane or the ene and use OL. I guess I will tell you that when you deal with alcohols, in here at least, there will always be all single bonds. There won't be any alkenes that have an OH in them. That's more than we want to get into. Okay, so this is all going to be just simple saturated compounds. Remember, saturated means all single bonds with somewhere there's an OH. What do you think?
What? Do you have like the worst stuffy noses?
You really can't smell it. That's interesting. Was anybody else not able to smell the trans?
How do you not smell them?
That's really funny.
That sounds bad.
Okay, for methanol, did I miss something here in the name methanol? Do I need a number on that one? I had a number on this one. No, you don't need a number on methanol. There's only one carbon. It's obvious where the carbon is going to go. Where the OH is going to go. On this one, I'll call it the parent. The parent is a pentane, but the pentane has an OH coming off of one of the carbons. And by the way, it's fine for the OH to be on the end carbon. If it was on the first carbon, it would be 1 pentanol. That would be fine. But this 2, so you can have 1 pentanol, 2 pentanol, 3 pentanol, whatever. Is it possible to have 4 pentanol? No, because that would be, if it were on that carbon, it would be 2 pentanol. Thanks, Emily. What do you think about that? No? It's not working for you? All right. So alcohols are pretty simple. And I will say this. I felt badly, I guess, just now saying that the parent was pentane, because it's really not. When you have an alcohol, the OH is considered part of the parent. So the parent here, like if there was a methyl group coming off of that carbon, it would be 4-methyl, 2-pentanol. Where the parent is the 2-pentanol, and you've got a substituted 2-pentanol somewhere. So we'll have to name compounds like this. just one more slide. And this last slide gives us